student friends, welcome back. The second part of this video that is on Baruch quantum mechanics. And this part will discuss about evidences in support of quantum mechanics and will show you how these evidences confirm the idea of quantum mechanics.
Kind of hypothesis, it's a purely experimental and purely have an experimental basis. So you can have all these things that emission of photoelectrons is instantaneous. That was not explained by classical mechanics, but here quantum mechanics can explain, because according to quantum mechanics, light comes in kind of light provides energy in terms of quanta, that means discrete energy. So a photon can instantaneously come out of a surface. While if you explain with the help of classical electromagnetic theory, it would take 1 month, maybe 1 day or 1 week or 1 month or maybe 1 year in coming out of while ejecting an electron from a metal surface with some kind of source of energy. So this was number one explanation. The second one was that the energy of the photoelectron remains the same whether the light source is bright or dim. That means if you put a very intense source of light or maybe a very dim light, even then also the energy of the photoelectrons will be same. That means what? It does not depend on the intensity of the source, light source. It is independent. That energy of the electrons which are being emitted from the from the metal is not actually related with the intensity of the source. It is actually related with the frequency. So this is thing that, but classically electromagnetic theory says that more the energy you put on the metal, the electrons will be ejected with more kinetic energy, higher kinetic energy. But this is not supported by experimental evidences. Experiment says that the photoelectrons are emitted, and even if you have a very intense light, the energy of the photoelectrons are same. And even if a very dim light can produce a high energetic photoelectron, that definitely means that it is independent of intensity. The energy of the photoelectrons is independent of intensity. So this famous photoelectric equation he put forward by Einstein, where kmx equal to h nu minus h phi naught equal to h nu h nu naught equal to h nu minus nu naught. So this equation is known as photoelectric equation and explains the emission of photoelectrons. For example, this phi naught means the minimum amount of energy that the radiation should have so that the electron can eject out. So and that phi naught is actually is related to a frequency known as threshold frequency, and that threshold frequency is known as nu naught here. You see that nu naught is that threshold frequency. So phi naught equal to h nu naught, and phi naught is the work function, the minimum energy that the radiation should have in order to eject an electron, and this nu naught is known as threshold frequency, that the minimum frequency that radiation should have in order to eject an electron. Okay. So it's obvious that if the frequency of the radiation is greater than that threshold frequency, only then that the photoelectron emission is possible. Suppose that threshold frequency is 550 Hz and the incident radiation has a frequency of 500 Hz. So in that sense that there will be no emission of photoelectrons. So we come to conclusion that the photoelectric effect is an experimental thing. It was explained by Einstein with the help of quantum hypothesis, and he used the equation 1.13, which is kmx equal to h nu minus phi naught, where phi naught is the work function related to threshold frequency as phi naught equal to h nu naught, and nu naught is the minimum frequency that the incident radiation should have in order to eject an photoelectron. Okay, so this was one support, and then the second one was that we suppose the Planck's theory is one Compton effect. Compton effect is actually the interaction between an electron and an X-ray. So when X-ray beam is falling on some block of paraffin, then there is an elastic collision between electron and photon. So when that photon strikes the photon gives some amount of energy to the electron and it loses some energy. So that means its energy is decreased and it emits with a lesser frequency after scattering. So this effect is Compton effect, and we observe in Compton effect that the scatter radiation has a lower frequency as compared to the incident radiation, incident X-ray radiation. So this quantum idea from Planck's hypothesis can be well predicted in terms of Compton effect, and we all can understand Compton effect through this quantum idea. Well, there's also some mathematical way of writing this. The expression is that there's a shift in the wavelength or the frequency, and which can be calculated like this. However, this is a course of study in atomic physics, so later course of time. So for the time being, let's take that it can be derived like this. And now the question arises whether we can have a classical explanation for this or not. The answer is that the classical explanation is not possible. Even if we do a classical explanation, the problem is that there's a continuous range of scatter wavelength, which means that there may be a Doppler shift effect, and ultimately there will be effect on the expression for this wavelength shift. So the wavelength, the change in wavelength, or whatever be the frequency or wavelength associated with the scattering radiation, can only be explainable with quantum idea. It's not by classical idea. So these are these important points that although we have taken this relation P equal to E by C, that is also classically available there. That is also true. And the second thing is that the evidences that we have put forward here in explaining these things, or the confirming the Planck's hypothesis, photoelectric effect or quantum Compton effect, they simply means that they are simply particles. We see that in photoelectric effect we use light, but we are not taking light as wave there. We are not using classical concept that is wave. We are using it as a particle. It's like a photon. And here also in Compton effect also, we are taking that X-ray radiation is nothing. It's consisting of some photons, where that photon is interacting with some electron and it's giving some energy to the electron, and as a result it is losing some energy, and the output is that the frequency of the scatter radiation is less than the incident radiation. That's all about Compton effect. So in both the cases, light or X-ray, they are not treated as wave, they are treated as particle. So we come to conclude that photoelectric effect or Compton effect, they firmly establish the fact that Planck's quantum hypothesis is a real thing, a thing that we must take care of to explain the experimental things like photoelectric effect and Compton effect. And thus we can say that a new thinking is required, because that we have now the belief to believe that new thinking, and thus the firm establishment of quantum mechanics was well underway. So we have put some assignments in these things, how the classical theory failed in explaining various phenomena, and how quantum mechanics explain all those phenomena. Just like the 6 examples we have taken, or we can take care of this photoelectric effect, black body radiation like this, and then photoelectric effect, how the photoelectric effect can be explained, Compton effect, how this can be explained, and basic assumptions of Planck quantum hypothesis, and question is whether it was successful at the initial stage. No, it was not successful. That's why that work by Einstein regarding photoelectric effect, Compton effect were important. And the 5th question is very important. Which one is more important in your daily life, classical or quantum mechanics, and why? This is very important. This will put you thinking that whether you are using classical mechanics in your daily life or quantum mechanics. If not you are not using quantum mechanics, then why? That's the thing. And then how quantum mechanics turns into classical mechanics. These are the things, and also that Bohr's correspondence principles with some theoretical explanation all about this, and also its significance. These are certain things that you can find in these videos, the two videos from where you can get the ideas and can solve out these problems. So hope that this video is also helpful for you, and we can now say that yes, that quantum mechanics is begin to work and we can understand quantum mechanics. Thank you so much.